All right, so we have this question. It says, example, debit and credit cards are widely used to make purchases. It says they reported 28% of purchases at a coffee shop were made with a debit card. So they were either made with a debit card or they were not. And hence, that's how I know this is a binomial. Remember, a binomial only has two outcomes. For 10 randomly, so I know my P, that they used a debit card, and I know my N is 10. And then it asks to find these different probabilities. So this is a lot of times how the formula is written, with this first C is the combinations of the number of ways that this can occur. They use pi for probability of success, X for the number of successes, and then 1 minus pi would be the probability of failure, and then n minus x, the number of failures. I kind of like this look over here. So this first piece, fraction, is the combination. Remember, the factorial symbol just means to multiply from that number all the way to 1. And then P, probability of success, X, number of successes, Q, probability of failure, which again is 1 minus P. I just find this way better. Well, what you can do in Excel, which is so nice, is you can set up a probability distribution. And how I would set this up, where X is the number of successes and P of X is the probability of this X. I know that I'm going to start at 0. Don't forget 0, because nobody could have used a card. And from here, I'm going to number these. And watch, this is something really nice about Excel. You can just drag this down and it knows to number. Now, how did I know to stop at 10? Because my sample size is 10. Okay, so remember the P, this is probability of success, and the N is sample size. So if I want to find the probability that nobody used a credit card, this is what's so beautiful with Excel. There is a built-in function. I want Excel to do this for me, so I start with an equal sign. Then I just start typing BINOM dot DIST. And it even tells you, returns the individual term binomial for the binomial distribution. I open a parentheses, and I will say it doesn't have to be capitalized. I just do it to make it easier to read. And look here, it even says what it wants. The number of successes, that's X, comma, the number of trials, that's N, comma, the probability of success, this value, comma, and cumulative says if you pick true, give me this value and everything above it. Well, there's nothing above it, but I want all of these to be just this individual probability. And typically for this distribution, you want this. Now, I am really lazy and I don't want to type this 10 times. What if you had 100 in your sample size? So what you can actually do, I'm going to kind of back up here and redo this, is the number of successes, this will change. But the number of trials will never change. So if I put dollar signs around that, and I did it so quickly with the F4 on my keyboard, then when I copy this, it won't change. I don't want the probability of success to change. And then once again, I type false. So this formula will give me the probability based off of this distribution that nobody used a credit card. So that's that probability. Because I absolute referenced, that's what these dollar signs mean, I can copy this formula. Check this out. Isn't that so nice? And it gives me the probability now of 1 person used a credit card, 2, 3, and so on. One thing you should always check is that your probability distribution should add sum to 1. So I'm doing an equal and a sum, and I close my parentheses, and phew, so that means I didn't make any errors. The other thing is, what are these funky things? Well, if you remember scientific notation, this says to move the decimal 5 places to the left, so it's basically 0, right? What I probably would do is highlight all of these, right click, format cells, number, And I know I at least need about 6 decimals, so I'm just gonna put 10 decimal places. So this way now I can see these exact values. So there's a very, very, very small probability, okay, that the purchase would be made all 10 out of this 10 sample size, all 10 purchases would be made with a credit card. All right, and so now that I have this probability distribution, what's kind of nice is in Excel, you can highlight these and you can do a bar graph. Now it kind of does something a little funky because it's showing the counts here, but what I can do is filter this, and I just click select data. I don't want the X values, I only want the probabilities. And then for my range, I just want these values. I want 0 through 10. So this is kind of nice because what this gives me is the heights of the bars. And you might say, well, what about these? Remember, they're basically at 0. But it shows me my probability distribution, and these heights of these bars here, as you can see, are based off of these values here. So you can kind of see where the higher the probabilities are. But probably more importantly is if I asked you, well, what's the probability nobody used the credit card? That's the 0. What's the probability 5 people used the credit card? The 5, the 0.08. Now if I asked you what's the probability, and sometimes we write this as X is less than or equal to 5. So what this is asking is 5 or less. I could just simply sum these probabilities. And so this would give me 5 or less. What if I wanted the probability more than 5? So if it's more than 5, notice I didn't put the equal sign there. So that would be 6 to 10. And of course, we would expect that to be a very small probability. And so this is just a very quick way with this formula to not have to do all this craziness to get these probabilities.